हेलो सर।
Hello, sir.
So, in the last period, we have started studying about the biomolecules. We have studied that biomolecules are essential for our life. They are like carbohydrates, proteins, nucleic acids, and lipids. We have even said that these biomolecules interact with each other in the presence of the minerals and vitamins and create the logic of life. The various types of biomolecules may be carbohydrates, proteins, nucleic acids, and lipids. First, let us start studying. We started studying about the carbohydrates. Carbohydrates are generally in the history. Uh, they are sweet in taste, and cane sugar, glucose, and starch are the very famous carbohydrates. In history, these carbohydrates were given the general formula CXH2OY, so they were considered as the hydrates of carbon, but later on came to know that this formula was given because of the formula of glucose like C6H12O6, which is C6H2O6, and sucrose like C12H22O11, which is C12H2O11. But when we look at the chemical formula of ethanoic acid, the molecular formula C2H4O2, which is also like C2H2O2. Same way at the same time, my dear students, when we study about the Remnose, Remnose is a carbohydrate, but its formula does not fix or does not follow the rule CXH2OY, and that is why the idea of hydrates of carbon has been not considered to be correct, but the name carbohydrate is given from that particular idea. Then we have studied about the definition of the carbohydrates, that carbohydrates are optically acting polyhydroxyaldehydes or ketones, or those compounds which gives such molecules on hydrolysis. We considered them as a carbohydrates. Carbohydrates were also known as sugar because they are sweet in taste. Same way, my dear students, we have studied about the saccharides. So in Greek language, saccharans means sugar, and that is why they are also called saccharides. Classification of carbohydrates. So carbohydrates on the base of the hydrolysis, they are classified in three major classes. One is monosaccharide, oligosaccharide, and polysaccharide. Monosaccharides are the carbohydrates which do not undergo the hydrolysis and do not produce any other, or do not produce simpler carbohydrates. The examples of these monosaccharides are glucose, fructose, ribose, and galactose. Then we have started studying about the oligosaccharides. Oligosaccharides are the carbohydrates that gives um, 1 to 20 simple monosaccharides. The examples of oligosaccharides that we have studied are the various class, or the various class of oligosaccharide we can study is disaccharide, trisaccharide, tetrasaccharide, depending upon the number of monosaccharide units they produce. Disaccharides give two units on two monosaccharide units on hydrolysis. Example, sucrose, maltose, and lactose. The two units given by this disaccharide may be same or not same. In case of in case of sucrose, it gives glucose and fructose, but in case of lactose, it gives glucose and galactose. So in these two cases, the monosaccharide units are not same, but in case of maltose, we find that the two units of glucose are being produced, and this way in maltose both the units of monosaccharide joined with each other are same. Then we studied about the polysaccharides. So polysaccharides are those carbohydrates which gives many monosaccharide units on hydrolysis. The examples of polysaccharides are generally the starch, cellulose, glycogen, and gums. Polysaccharides are not sweet in taste, and that is why they are also called non-sugars. And then we studied about the classification based on the reducing character. That means based on the tolerance and failing taste. We have studied that carbohydrates may also be classified as reducing sugars and non-reducing sugars. The reducing sugars are those carbohydrates which reduce the failing solution and tolerance reagent. They are called reducing sugars. All monosaccharides, whether they are aldose or ketos, are called the reducing sugars. So please remember that all monosaccharides are reducing sugars. In disaccharide, maltose and lactose are reducing sugars too. So in disaccharide, we have studied the maltose and lactose are also reducing sugars. Now we want to study about the non-reducing sugars, my dear students. Carbohydrates or sugars in which aldehydic or ketonic group are bonded, they are bonded means they are not free. This C double bond O group, when they are not free, they do not reduce the failing or tolerance reagent, and these kind of sugars or these kind of carbohydrates are known as the non-reducing carbohydrate. For our syllabus, the sucrose is the best example of the non-reducing sugar. Please remember this example, that we have only sucrose, which is a non-reducing sugar, in our syllabus of 12th standard. Then, my dear students, we want to study about the monosaccharides. So monosaccharides are further classified on the basis of the number of carbon present in them. So on the basis of the number of carbon present in them, monosaccharides can also be classified. So monosaccharides can also be classified on the basis of the functional group present in them. So we classify monosaccharides in a various ways. One of them is on the basis of the number of carbon, another is the functional group present in them. So let's first look at the aldose. If the monosaccharide contains an aldehyde group, it is called aldose. If the monosaccharide contains ketone group, it is called ketose. On the basis of the number of carbon, monosaccharides are called triose, tetrose, pentose, hexose, heptose, etc. Triose means 3 carbon, tetrose means 4 carbon, pentose 5 carbon, hexose 6 carbon, and heptose 7 carbon. On the basis of this way, these monosaccharides are classified. Now you can understand them, that we have classified, like we have made a table for them, that we have number of carbon, general term, whether they are aldehyde, then what is the name, and if the functional group is ketone, what is the name. So if we have 3 carbon, the general term is triose. For aldehyde, we call it aldotriose, and for ketone, we call it ketotriose. For 4 carbon, tetrose. So for aldehyde functional group, we call aldotetrose or ketotetrose. For 5 carbon pentose, that means aldopentose or ketopentose. For 6 carbon hexose, we can say aldehyde group aldohexose, ketonic group ketohexose. For 7 carbon, we write heptose. So for aldehyde functional group, we write aldoheptose, and for ketonic functional group, we write ketohexose. So this is how we can even understand the classification of the monosaccharides, and we can have various types of monosaccharides, whether they are aldotriose, whether they have the functional group aldehyde or ketone, or whether they have the number of carbon 1, 2, 3, 3, 4, 5, etc. Now, my dear students, let's study about a very important monosaccharide, which is known as glucose. So glucose is a very important point for our study, and we will study glucose in detail. First, occurrence. Glucose occurs freely in nature as well as in the combined form. So we find glucose freely in the nature as well as we find glucose in the combined form. Glucose is present in the sweet fruits and honey. My dear students, in almost all type of sweet fruits, we will find glucose, and we will also have in honey glucose in a good amount. Ripe grapes also contain glucose in a large amount. So if we have grapes, these grapes contain glucose in a large amount. Methods of preparation of glucose. So from sucrose, we can prepare glucose from sucrose. Sucrose is nothing but your cane sugar, which we use it at our home. In sucrose or cane sugar is boiled with, if sucrose or cane sugar is boiled with the dilute hydrochloric acid or dilute sulfuric acid in alcoholic solution, glucose and fructose are obtained in equal amount. So let us write the chemical equation. Your sucrose C12H22O11 in the presence of water and acid in the alcoholic solution, we get glucose C6H12O6, and we get fructose C6H12O6. Remember, my dear students, that glucose and fructose have the same molecular formula, and their molecular formula is C6H12O6. They just have the different structures, but their molecular formula is same. Now, my dear students, we want to prepare glucose from starch. So let us see how from starch glucose is prepared. Commercially, glucose is obtained by hydrolysis of starch by boiling it with the dilute sulfuric acid at 393 Kelvin under the pressure. So please pay attention, my dear students, that we have starch or cellulose when it is heated in the presence of the acid H2SO4 at 393 Kelvin and 2 to 3 atmospheric pressure. From this starch, we get n number of glucose. So we get huge amount of glucose from this starch. Now, my dear students, we want to study about the structure of glucose. So glucose is an aldohexose, so it has aldehyde as a functional group. Glucose is known as dextrose. Please remember that glucose is known as dextrose. So in hospital, if you go and meet a patient, you will find that the bottle which is given to the patient, it has dextrose written on it. Glucose is the monomer of many other large carbohydrates. So glucose is a monomer of many other polymers, and these polymers are large carbohydrates like starch and cellulose. So both these starch and cellulose are the polymer of glucose, and they have huge amount of glucose present in them. Glucose is probably the most abundant organic compound on the earth. So, my dear students, on the earth, the compound which is most abundant is glucose. You will find glucose everywhere in the nature, and this is how glucose is the most abundant compound. Structure of glucose is derived from the various chemical reaction it gives. So, on the basis of the various chemical equation or various chemical reactions, glucose gives in various conditions. On the basis of that, the structure of glucose is derived. Please remember that the molecular formula of glucose is found to be C6H12O6. So molecular formula of glucose is C6H12O6. And now, my dear students, we will study the various reactions given by glucose to understand the structure of the glucose. So let's pay enough attention here, because this is the most important part for you in your exam. Generally, there will be at least one question, at least 1 mark question from this point of discussion, that evident reactions for the structure of glucose. So we will study all these evident reactions for the structure of glucose, and first we will start with the first we will start with the reactions of glucose with HI, that is hydrogen iodide. So when our glucose C6H12O6 is heated, or there is a prolonged heating with hydrogen iodide, it gives us the normal hexane. So when we get this normal hexane, we can see that in normal hexane, all the carbons are present in the same linear carbon chain, and glucose has 6 carbon, all these 6 carbons are present in the linear chain, and on the basis of these reactions, we can conclude, or we can easily say that in glucose, all the 6 carbon are present in a linear chain. So this is what we conclude from these reactions, that all the 6 carbon in glucose are present in a linear chain. All the 6 carbon in glucose are bonded with each other and making a line. Now, my dear students, we want to study about the another reactions of glucose, that is the reaction with NH2OH, which is known as the hydroxylamine. So glucose, when it reacts with the hydroxylamine, it gives oxime, which is known as glucose oxime. Same way, glucose, when it reacts with HCN, it produces, that is hydrogen cyanide, it produces cyanohydride, which is called the glucose cyanohydrin. So, my dear students, as we have studied in the chapter of the aldehydes and ketones, that aldehydes and ketones on hydroxylamine gives oxime, and reaction with hydrogen cyanide gives cyanohydrin, and that is why we can conclude that glucose has the presence of carbonyl group present into it. So from these two reactions of glucose, that is the reactions with hydroxylamine and hydrogen cyanide, we can conclude that glucose has got the carbonyl group present with it. Now, my dear students, we want to study a very important reactions of glucose, that is the reactions of glucose with HNO3. Please pay attention and understand these reactions well, because it is the only reactions that requires little more understanding, or else everything is very simple to understand about the structure of glucose. Now glucose, when it reacts with the mild oxidizing agent, it produces gluconic acid. So glucone, when it reacts with the mild oxidizing agent, it produces gluconic acid. When you look at the gluconic acid, you will find that the last carbon has a CH2OH group present on it. On first carbon, we have got COOH. Now, my dear students, we have studied that with mild oxidizing agent, the aldehydes gives carboxylic acid and alcohol gives aldehyde. But this alcohol is not converted to aldehyde, it remains as an alcohol. So we can say that here there is an aldehyde group present on the first carbon. So by the reactions of glucose with bromine water with the mild oxidation, as the product has got COOH group on the first carbon, we can say that carbonyl group is present as an aldehyde into the glucose. So glucose is an aldohexose because in glucose the carbonyl group present, it is present as an aldehyde group. That is what we confirm by the reactions of glucose with the bromine water. Now what happens, this gluconic acid, when it is oxidized with the HNO3, which is a strong oxidizing agent, this gluconic acid gives us the saccharic acid, and this saccharic acid has got this CH2OH converted to COOH. So my dear students, again this gluconic acid, when it is oxidized with the strong oxidizing agent, this CH2OH group is also converted into COOH. Now if we directly oxidize glucose with the help of the strong or vigorous oxidizing agent, that is HNO3, we directly get saccharic acid, where on the first carbon and the last carbon we have COOH. That means, my dear students, as the CH2OH group is available over here on the last carbon, in glucose also on the last carbon we must have the CH2OH group, which is not actually oxidized by the bromine water, which is a mild oxidizing agent. And on the basis of that, we can say that primary alcohol group is present in the glucose. So remember that by these two reactions, that the reactions of glucose from bromine water, and then we get gluconic acid, which on oxidation gives the saccharic acid, as well as glucose directly gives saccharic acid on strong or vigorous oxidation. We can realize, we can understand that glucose has got primary alcohol group, which is known as the CH2OH group. This is primary alcohol group which is present into the glucose, and from this structure we can easily understand that this primary alcohol group is already present on the last carbon of glucose. Now we have one more reaction to understand, and this reaction is actually not complicated, it is very easy to understand. So when glucose is allowed to react with the acetic anhydride, my dear students, this acetic anhydride, that is CH3CO twice into O, for one glucose, for 1 mole of glucose, my dear students, we need 5 acetic anhydride for the reaction, and after the reaction glucose forms the glucose pentaacetate. Once again, glucose then undergoes the acetylation reactions with the acetic anhydride. For 1 mole of glucose, we need 5 mole of acetic anhydride, and the product that we obtain is glucose pentaacetate. That means in glucose, we have 5 OH group, 5 alcohol group, 5 OH group are present, and all 5 OH groups are bonded to the different carbon, because 5 molecules of acetic anhydride required for the acetylation, and that is why 5 OH group are present, and all 5 OH group are present on a different carbon, because 2 OH group on the same carbon is not stable and glucose is stable. So my dear students, please remember that on the same carbon, if there are 2 OH group present, the structure is not stable. But here, that is why all these 5 OH group present in glucose, because glucose is stable, then we can say that in glucose, all the OH group present, they are bonded to the different carbon. So here, my dear students, we complete our discussion about the structure or the various evidences reactions for the structure of the glucose. Now, is there anything which you do not understand for these reactions, you can ask me, or else we can move to understand the structure of glucose. बच्चों अगर कुछ समझ में नहीं आया तो प्लीज पूछ लीजिए. बच्चों मैं आपसे पूछ रहा हूं, अगर कुछ समझ में नहीं आया तो प्लीज पूछ लीजिए. कोई ऐसा है जिसको कुछ समझ में नहीं आया है तो प्लीज पूछ लीजिए. कोई भी ऐसा नहीं है जिसको कुछ समझ में नहीं आया तो आगे चले. एटलीस्ट बोल दीजिए कि सब समझ में आ गया, इतना तो बोल दीजिए.
समझ में आ गया.
ओके चलिए, अगर सब कुछ समझ में आ गया है तो अच्छी बात है, और अगर समझ में नहीं आया तो प्लीज पूछ लीजिएगा. ओके देन लेट्स मूव फॉरवर्ड. दैट्स वंडरफुल दैट यू हैव अंडरस्टूड एवरीथिंग. देयर इज नथिंग बेटर देन दैट. So let's move forward. So now, my dear students, we can easily understand the structures. Now let us see what we have found and study it in detail. We found by the different reactions. We found by the different reactions that glucose has 6 carbon in the straight chain. Number 2, glucose has a carbonyl group. Glucose has 5 OH group. CH2OH group is also present in glucose. One aldehyde group is also present in glucose. From all this information, my dear students, we can write the structure of glucose. So you can see here, we have the structure of glucose in front of you, my dear students. You can see the structure very well. I'm just trying to show you the structure. Can you see the structure on your screen, my dear students, a complete structure of glucose?
Yes, sir.
You can see that in the complete structure of glucose, we have arranged all the 6 carbon in the straight chain. On the last carbon, we have put CH2OH group. All this carbon have got at least one, on each carbon we have arranged at least one OH group. So all 5 carbons are bonded with the 5 different OH groups. At the same time, my dear students, the first carbon has got CHO aldehyde group present into its structure. And this is how we can, from all these various reactions that we have studied, or which were the evident for the structure of glucose, we can understand the, or we can derive the structure of glucose in this manner. Now you can even realize that if we give number to the carbon 1, 2, 3, 4, 5 and 6, then you can see that on the third carbon, the OH present is on the opposite side, or else on the second, third, fourth and fifth carbon, the OH present on glucose are on the same side. Glucose can be written as plus glucose or minus glucose depending upon the rotation it do with the polarized light if passed through it. So in haloalkanes and haloarenes, my dear students, we have studied about the method how to determine positive and negative sign. So if the light is moved or rotated clockwise, we will call it plus glucose, and if the light is rotated anti-clockwise, we will call it minus glucose. Now on the basis of the structure of the glyceraldehyde, please pay attention here. We have the structure of the glyceraldehyde. You can see that glyceraldehyde is having 3 carbons. On the first carbon we have, like glucose, on the first carbon we have CHO. Like glucose, on the last carbon we have CH2OH. And on the carbon which is second carbon, if HO group is present on the left side, we will call it the D-glyceraldehyde. So we will call it as a plus glyceraldehyde and minus glyceraldehyde. So now this plus glyceraldehyde and minus glyceraldehyde, the minus glyceraldehyde is having OH on the left side, the plus glyceraldehyde is having OH on the right side. So on the basis of the structure of the glyceraldehyde, we can give names to the different sugars, either D or L. Please remember that we call glucose as a D plus glucose or D minus glucose. So how do we give this name D and L, that is capital D and capital L, to the glucose? So to give names to the glucose on the base of the plus D and capital D and capital L, we use the structure of glyceraldehyde. When we study the structure of the glyceraldehyde, then the OH group in the plus glyceraldehyde is on the right side, and in the minus glyceraldehyde, the OH is on the left side. So the plus side glyceraldehyde, we call it capital D glyceraldehyde, and when we have the OH on the minus side, we call it capital L glyceraldehyde. Same way we can apply the same thing for the glucose. So let us see how do we do it. The following method we use, but this is done according to the following method. So we apply the following method. Let us see what is the method. For the given sugar, find out the number of carbons present. Then we need to find out the functional group. Give them the numbers. Find out the carbon which are chiral. Which chiral carbon has got the highest number, and COH in the bond, OH which is bonded to this carbon. So to give the capital D or capital L symbol to the various sugars, my dear students, we need to follow one particular formula. Now what do we do to give this name? First we need to find out the functional group. So in glucose, if you look at the various carbons, we have this CH2OH, here we have CHO, then here we have OH this side, OH here in this side and H, and then we have H and OH. 1, 2, 3, 4, 5, I made a mistake. Let me do it in another manner. So, why has it not been changing? So this is even sorry dear students, I have wasted some of your time. Let me do it once again. So this, if you look at this, also is having OH and H, and the final carbon has got CH2OH. Now you can see that the various chiral carbons in glucose is, so first of all we need to find out the functional group. So this is the functional group. Now we generally give the numbering from the functional group. So this is first, second, third, fourth, fifth and sixth carbon. This is how we give numbers. Now these all carbons are chiral carbons because the various group bonded to them are different. So here only the sixth carbon is not chiral carbon. So the highest number that is given to the glucose is the fifth carbon. On fifth carbon we can see that OH is present on the right hand side, and as the OH is present on the right hand side, we can say that our glucose is having D or L name. So let's glucose mainly exists as a D glucose and most of the D positive glucose, but some way D minus glucose, L plus glucose and N minus glucose are also found into the natures. So my dear students, when we glucose D and L forms, there are few tests. Okay, just one more thing I would like to share with you. When you look at the glucose, see the OH part which is present on the right side into the fifth carbon of glucose, On the fifth carbon of glucose, OH was present on the right side, and that is why this type of glucose structure that we have seen, we call it as a D plus glucose. Apart from the D plus glucose, we can get the D minus glucose, L plus glucose, and L minus glucose even. So now, my dear students, we want to understand a few tests which are not given by our glucose. What are these tests? Let us study them. Glucose does not give 2,4-DNP test. That is 2,4-dinitrophenyl hydrogen test, which is generally given by the normal or other aldehydes and ketones. Glucose does not give Skiff's test. So glucose, like this aldehyde, when they reacts with NH2 or ammonia, they gives the C double bond and H. This kind of compound, which is known as the Skiff's reagent, and this Skiff's test or Skiff's reagent is or Skiff's test is being not given by glucose. Same way, glucose does not give hydrogen sulfide test. That is the test with NaHSO3. So these all tests we have studied when we were studying about the aldehyde and ketones, and these tests were not given positively by glucose. So 2,4-DNP, that is 2,4-nitrophenyl hydrogen test, which is common test given by the free aldehyde or ketonic group, but glucose does not give this test. That means the ketonic or aldehyde group present in glucose or the carbonyl group present in glucose is not free. Now let's think about this Skiff's test. This test is invented and named by Skiff, Hugo and Skiff. It is a chemical test for the detection of the aldehydes. Reagents used for this Skiff's test are the fuchsin or para-rosaline and sodium bisulfite. Both para-rosaline and fuchsin are sodium bisulfite. When react with each other, we get Skiff's reagent. Skiff reagent is colorless, but when an unknown sample is added to this reagent, Skiff reagent, that is fuchsin or rosaline, and sodium bisulfite, we get the magenta or pink color is developed in this Skiff's test. Human skin also contain aldehydes and ketones, and it can also be stained with the Skiff's test or Skiff's reagent. Our skin also develop the pink or magenta color with this Skiff test. Now, glucose does not give this sodium bisulfite test also. That glucose, when it reacts with NaHSO3, it should give this kind of products where SO3H and OH are being added to the carbonyl group, but glucose even does not undergo this kind of reactions. So from the above information, we get that we come to know that in glucose, we do not have carbonyl group in the free state. Please remember that from these three tests, which is not given by glucose, which are not positive for glucose, we can say that the carbonyl group present in glucose is not free. While crystallization, so when we were trying to crystallize glucose, during this process is known as crystallization. So while crystallization process is done for glucose, it is found that glucose found in a different crystalline conditions. So glucose during the process of crystallization, it is found in a different way. If aqueous concentrated solution of glucose is crystallized at 303 Kelvin temperature, that is at 30 degree centigrade temperature, we get glucose which has 423 Kelvin, that is 146 degree centigrade melting point. Same way, if we crystallize glucose in the another manner, that if hot and saturated solution of glucose is crystallized at 371 Kelvin, that is 94 degree centigrade, we get glucose which has 423 Kelvin, that is 150 degree centigrade melting point. So the melting point, my dear students, that we get here the glucose which is found is having the melting point 419 Kelvin, but here the glucose that we found has got the melting point that is 423 Kelvin. So these two glucose which are obtained by the different reactions have got the different melting point. It means we have two different type of glucose which have different melting point. So what are the two different type of glucose that we have? Let's revise once again. Whatever we studied, let us revise. Crystallization is, if done for aqueous solution of glucose, we at 303 Kelvin, for concentrated solution glucose, we get the glucose which is having the melting point 419 Kelvin. But for saturated solution of glucose which is hot and saturated, we get a glucose which is having the melting point of 423 Kelvin. These two crystalline forms shows that they might have different structures and thus they need to be different from each other. Now we have two different information.